In this video, we will be working through Chapter 3 of the XPDRAINAGE introductory tutorial. As one might imagine, we're going to pick up at the end of where Chapter 2 left off. And we'll begin, as the end of Chapter 2 states, that we'll select Go and run the full hydraulic analysis of this treatment system. And the first thing that happens when we run the full assessment is we have a summary of all of the stormwater controls in our network. In this case, stormwater controls are what we're going to refer to as the ponds. In this case, the underground detention system, swales, rain gardens, so on and so forth. We only have one stormwater control in this model, and we'll see that if we select all storms, in critical storm, we can look at the 3 different rainfall events which have been run, and we'll see clearly the critical storm in this case is the 100-year rainfall event. When we look at these summaries, in particular the stormwater control summary, this information is extremely useful. It's how high did the water get, how fast, and how much was inflow, how much was outflow. But really, the first thing while I'm designing that I'm going to want to look at is over here on the right, is percentage available. So we'll look at this and say, oh, wow, we only have 6% available space in our 100-year storm. So let's get a better sense for what that means. So while the plan view is really useful, this flow path in profile can tell us a lot of really useful information. So the first thing I might do is to zoom in. And I can turn off this lower table by selecting that icon there. And I can select the 100-year event from this drop-down menu. And now I could play an animation, you'll see, of inundation throughout our facility. Now what I want to look at is right here kind of at the peak of our storm. See, water gets above these chambers. Well, how can that be? So you can select something, double click directly in the profile view to look at the input. And we'll notice here we have these embedded parameters. So we're saying that there's fill above the top of these chamber arches. Pretty common. And we're allowing volume to fill up above those chambers. So in the results, when it says there's 6% available space, that means there's only another 6% of volume in this storage lens above our arch chambers before we fill up and overtop this facility. So in this case, this facility is working quite well. This is a pretty well optimized facility. So let's whittle this back down to, now that we understand what this stormwater control summary is showing us in terms of available percentage, we can dive into look at some other results. So let's start with looking at a connection summary. This will be flow in, flow out, and ultimately capacity for all of the pipes in our network. So we could go to critical storm. Again, as you can imagine, the 100-year event is going to be critical. And one design column to look for is flow over capacity. That's an indication of how well water is moving through these pipes, in this case, versus what the Manning's equation capacity full flow would say should be allowed. In this case, the pipes perhaps are a little oversized. So you see we're well below 0.8 or even 1 in this flow divided by capacity relationship. So we have water really well flowing through our network. We can dive deeper into individual results. We could look at individual results here. I could even just right click on an item and say show results. And now we're going to get a table. I'll whittle this down to show just inflow and outflow. I'm scrolling with my middle mouse button to zoom in, and I can hold down the middle mouse button to pan left and right. But again, if I whittle this down to just inflow and outflow, of course, rainfall, we'll see the comparison that's being made. I could switch rainfall. We could see what the 5-year event looks like. We could even go through and look at detailed result summaries. So let's move back to that profile. Again, you could right click on the flow path and show profile. Similarly, under results, there's show profile. And you'll see that you can scroll in with your mouse to move around your network. I'm holding down the middle mouse button to pan around. Similarly, you could use some of these controls to pan and move. And the annotation is dynamic, as in it changes as you move the view along this system. Quite useful in really understanding what's happening in this network. Again, as I just showed before, I could turn off this lower table section using this item right here to only simply show the long section and the animation. These are all great for understanding the results of an individual phase. Something we typically would want to do in design is we want to compare different phases. In this case, I have an existing site and my developed conditions. So under results, I could select phases report. And if we ensure that both existing and developed phases are selected, if we select update preview, we'll look at, we have all 3 rainfall events and a comparison between phases and between storms. I could scroll to the bottom of this list and I could look at inflow, outflow between these different events. The tabular summary is usually going to be a little clearer, and we'll see that overall total outflow about 1.1 cubic feet per second versus 1.9 in the existing event. So we're mitigating over that 100-year existing site adequately. And that concludes Chapter 3 of the introductory tutorial to XPDRAINAGE.